Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. In this episode, we will be going over highlighting selected blocks, so that should be very quick and straightforward. We will also be going over adding multiple blocks at the same time, so you can see that as I'm clicking over here, all those objects only get added once, and then you can see once I deselected all those, they turned off. So all those objects were only added once. We will also go over fixing the grid lines. All this should be fairly quick. So you can see that the grid lines work when you zoom out and when you zoom in. And I also added some optimization so that as you zoom to a certain point, the grid lines just sort of disappear. So we may or may not talk about that today. And then we will be adding in physics callbacks to our components and physics functions. So we'll be adding the ability to raycast into the world and have a callback call some component. So like player controller has callbacks that tell me, hey, I've begun to collide with an object, and it tells me what the object was, what the contact normals are, and all that good stuff. So we will be implementing all of this today, and yeah, let's get to it. Okay, let's get around to doing that first thing that I talked about, which is highlighting the blocks when you select them. Well, that is actually fairly simple. And I don't know if this is the standard way people do this, but hey, it was the simplest way that I could get this done. So basically, inside of our properties window, which you can see I just switched to, I'm going to add a list that is tracks with our active game object. So the indices will be the same, and honestly, it doesn't really matter too much, but it is kind of important. So it'll just be a list of vector4f, which is going to be our active game object's original or OG color. And basically, this is just going to contain the color they were before we selected them, because we're going to be changing their colors on select. And then we, of course, want to initialize that list just so that we can use it. So one thing we will want to do is scroll all the way down to where we have our clear selected function. Now, actually, I guess it probably makes more sense to do the add active game object function first. So when we add a new active game object to our list, what we want to do is we basically want to get a hold of its sprite render, if it has one. If it doesn't, I guess this will really be too useful, but we'll go ahead and get that. So we just get the sprite render.class, and then we can say if the sprite render is not null, then we just want to say this active game objects dot or OG color dot add a new vector4f and copy the sprite's color. So we simply make a copy of its color. And then we can say sprite.setColor, and we will just set it to a new vector4f, 0.8f, 0.8f, 0, 0.8f. So it'll make it like a yellowish color that is semi-transparent. So that should be good. And then we'll say otherwise, since we want this list to basically track with the active game objects exactly, we'll just say this.active game objects OG color.add new vector4f. So since there's nothing there, we don't really need to add a copy of the color. We just need to add an empty vector so that we keep these lists indices the same with the objects that they have. Okay, and then once we clear selected, in order to get it to set back to the original colors that they had, we'll say if active game objects.ogcolor.size is greater than 0. And then we'll just loop through. We'll say int I equals 0, and then we'll say for game object go in active game objects, and these sizes should match up. Then we'll just say sprite render spr equals go.getComponent sprite render dot class, and we will simply say if the sprite is not null, then we'll say sprite.setColor active game objects OG color dot get I, which should set the color to the original color that it was. And then of course we just need to say I++ so that we keep that index current. And then we can clear the game objects, but we also have to clear the OG color just to make sure we keep that all the same. Now, if we go in and we select multiple objects, we're going to get an error. Let's see what's going on. It says we get a null exception, and that is because something is going on. Oh, because I set the wrong list here. We want to set active game objects OG color to a new array list here, not the active game objects, which we've already set. Okay, now if we go ahead and select multiple things, you can see it sets them all to a different color, and if we click off, it resets them. And these ones aren't quite right. Are they a different color? Oh, and you know what? I think these ones look different because this is a block underneath the block, right? So if we delete, we actually had multiple blocks placed there. And that's another thing we will be fixing today. So I'm just going to go ahead and delete everything so that we can sort of have a fresh slate. Okay, play stop that just to save that. Now, if we go back, we basically want to improve it so that when we're placing multiple blocks down, right, when we go and do that, we don't get doubles placed down on accident, which you can see I got a double there because we just placed it over the same area. So we can do that by just going into our mouse controls class, and we'll add in a little bit more of a helpful thing. So first of all, we're going to sort of get rid of the concept of the debounce time for placing blocks, and we're going to change that to 0.2f. And then we're going to go down here, and when we're checking, so we say if holding object is not null, I'm going to get rid of this completely because we're going to check something different. What we're going to do is right here when we say if they press the left mouse button, instead of placing, we're going to say float half width equals, and we're going to get half the width of the grid width. And then we're going to say half height equals settings dot half the grid height. And then we're basically going to say if the mouse listener is dragging, so if they're dragging the mouse, which would happen if they're just moving it, right? And we're going to create this function where we basically check to see if there is already a block in the square that they're trying to place the object in. So we'll say, and there's not a block in the square. We're going to say holding object.transform.position.x minus half width. And you'll remember holding object transform position x is the center of the grid square that we're hovering over right now. And then we'll say holding object.transform.position.y minus half the height, which should give us the appropriate thing. So once we implement this function, not block and square, and I'll move this to a new line, we should basically be checking to see that there's not already a block in the square. Otherwise, we're checking if the mouse listener is dragging here, and we also need a bracket here, and we're just going to surround the place function inside of this bracket, and we're going to remove that debounce equals debounce time because that doesn't really matter. And then we'll say otherwise if the mouse listener is not dragging and debounce is less than 0, so this is where we will use a debounce. We'll say place, and then we'll just say debounce equals debounce time, which should do it so that if they're single clicking, they won't double place on accident. Now, this block and square function is the part we have to now implement real quick. So how does this work? Well, basically what we're going to do is we're going to scroll all the way down, and then we're going to say private boolean block in square, and this will take in a float x, float y. So that's basically the bottom left corner of the square, and we're going to say properties window equals window dot get IamGUI layer dot get properties window. Then we're going to say vector 2f start equals new vector 2f xy, vector 2f end equals new vector 2f start dot add, new vector 2f settings dot grid width and settings dot grid height, right? So that should be, the start will be the bottom left corner, end should be the top right corner of the grid square that the mouse is currently hovering in. And then we can say vector 2f start screen f equals, okay, and the reason I'm calling this f is because we're going to be using floating points here, and you'll see in a minute why. So we'll say that's the mouse listener dot world to screen, and we'll give it our start. So we're converting from world coordinates to screen coordinates, and then we want to do the same thing for our end screen. So we say end screen f equals mouse listener dot world to screen end, and then we'll say vector 2i start screen equals, and then we'll say new vector 2i, and we'll cast it. So we'll say int start screen f dot x, and I'm gonna add 2. So this will basically like add 2 pixels to where the mouse is in. That way we're kind of going inside the border of the box a little bit, so we don't pick up any objects in a different grid square. And then we're gonna say int start screen f dot y plus 2, and then we're gonna say vector 2i end screen equals new vector 2i, and to keep it even, I'm gonna go end screen f dot x minus 2 and int end screen f dot y minus 2. So that way we just kind of get a little bit inside the grid border instead of, that way we don't accidentally pick up extra objects or something. And then we can just say float game object IDs equals properties window dot get picking texture dot read pixels, and then we'll give it the start screen and the end screen. And that should give us all the game object IDs within this. And we'll do something very similar to what we did above, and we'll just say for int I equals 0 until I is less than game object IDs dot length I plus plus, and we'll just say if game object IDs I is greater than or equal to 0. So if we have a valid game object, we'll say game object picked object equals window dot get scene dot get game object, and we'll say int game object ID is I, so we just have to cast that to an integer. And then we'll just say if the picked object dot get component. So if it doesn't have the non-pickable class, that way we don't accidentally select the object we're holding, then we can just return true. All right, and then we'll return false other way. So we're just looping through all the game objects, and if we find one that's a non-pickable, then we'll say, hey, there is a block in this square already. Otherwise, we just return false. So it's all conceptually kind of simple. We just have a lot of casting and stuff going on here, which kind of bloats the size. But with this in place, we should be able to go into here, and if I click and drag, something's not working because I'm getting a lot of game objects, so it's clearly duplicating. Let's see what's going on. And I know exactly what the problem was. Right here, I'm checking to see if it doesn't have non-pickable. No, we want to check and see if it, yeah, I was checking to see if it did have it. We want to check and see if it doesn't have it. If it doesn't have it, then we return true. And with that change, we should be good. So if we go back into here, you should see over in the scene hierarchy panel, as I add objects, it only adds one at a time. So this means we are only ever getting one. And then we can also see this. If I go ahead and just select all these and delete, you can see there was only one of each in the squares. So with that out of the way, we now have like a little bit more of an easy to develop editor, right? We can select multiple objects. We can drag without worrying about like accidentally doing too much. We can select multi, duplicate, and we can't really move those yet. And it seems like the duplicate button is not working, so maybe we don't have that enabled yet. Okay, and I have a feeling the duplicate key is not working because of this other change I made. So real quickly, inside of key listener, just go ahead and instead of doing this thing for key begin press, which is kind of stupid because if you press one key and you want to check it in multiple different functions, it's not going to work right. Because if you're checking one function, if the D key is pressed, then you check in another, it'll already be set from the one function. So instead of doing this, we're just going to return get.keyBeginPress key code. And we're not going to do any bounds checking, just so that we know if something is wrong. And then we're going to add in one frame in here to help us out. And this is going to be public static void end frame. And we're just going to say arrays.fill get.keyBeginPress false. That way, every frame, we're basically saying, okay, if we began to press a key on this frame, we are no longer going to do that. And then we should be good. So this should only trigger once per frame. And then the next time they press down, it'll trigger again, since we have it on press, setting that to true. Okay, so with that, we should be able to go into our window class real quickly. And then we can just add right by mouse listener.endFrame, we can say key listener.endFrame. And that duplicate function should work properly now. Let's see. So if I go ahead and do that, and then I just duplicate. Okay, yeah, now you can see we've got duplicated objects. If I delete those, you can see we have some extras there. Okay, so with all of that out of the way, let's move on to physics, okay? I'm gonna go ahead and show you guys how to implement the different physics callbacks and stuff using Box2D. Now, you guys know me though, and before I go ahead and show you how I implemented these things, how do you find out how to implement callbacks and stuff for Box2D? Well, you go to Box2D's documentation, which is plentiful and helps you a lot. Exactly how I figured this out was I just looked over here and I was like, okay, I want to add callbacks for when two bodies begin colliding. So I looked in bodies, and then you can see, let's see, is there anything in here? No, there's nothing that talks about collisions. Well, what about contacts? Okay, that probably makes more sense. And then contact listener. And then I go into here, and if I click onto contact listener, you can see he says you can receive contact data by implementing this. And so then I implemented it, and I started experimenting, and I came up with a solution that I thought was pretty good. And I'll show you what that solution is now. But if you ever want to do this in the future, look to the documentation. It helps a lot. As for how I implemented the contact listener though, let's go into physics, and we're going to go ahead and add a new class. And we'll call this Jade Contact Listener. I'm not using the name Jade anymore because it's actually used by Blizzard. I think they have an engine called Jade. But since the series started with Jade, it's going to be Jade for this series. Okay, so we have our Jade Contact Listener, and this implements Contact Listener, which is an interface that we can import from Box2D. And if you hit Alt-Enter, you can say implement the methods, which will get you all the function definitions. And we basically just want to create something that gives us an easier way, because right now, you can't really easily get this to all of your components, right? What we ultimately want to be able to do is say something like, hey, I have some specific component. Maybe it's the sprite render. More likely, it'll be a player controller or something, which we will see. And you want to be able to say like override public void beginCollision, right? And this will basically give you a game object, and it'll give you other stuff, and then you can start handling collisions, right? That's how simple it will be. So the way we can do that is we can use this as sort of a wrapper and then give us that functionality. This also makes it nice if you ever want to switch physics engines. You don't have to change too much. You just have to keep that functionality the same for the components and sort of forward that functionality to the new engine or the new physics engine. So what we can do is, if you see contact has this thing called user data. Let's see. Well, you can say get fixture. So this is like the collider, and fixture A is collider on object A. And then you can see this has user data. And user data can be whatever you want. If we look at the type, if you control and you hover over this, you can see this is just an object. So we will be setting that object to our game objects, which we can do by going into physics 2D. And we're going to go ahead, and when we go and set certain things, like you can see we've got circle here. We'll do box collider since this one's a little bit more simple. But you can see we have the shape, and we say shape.set as box. And I'm actually going to change the way we do this a little bit more. Instead of doing this body.create fixture, what we're going to do instead is we have our shape. Okay, and we're going to change the way we do this a little bit more. We're going to abstract some things and just make this a little bit simpler. So let's go ahead and we're going to add in a function, and we're just going to call this private void add box2D collider, which will take in a rigid body, RB, box2D collider, box collider. And this is basically just going to be everything we had in here. This way we can abstract this logic away, and we'll add it right here. And let's actually make this public because we may want to use this from external classes. And then what we're going to do is, first of all, we're going to say body equals rb.getRawBody. So we're going to get the raw body from that, the box2D body. And then we're going to say assert body is not null. Raw body must not be null, which we'll make sure is always true. And then we need a shape. So we'll say polygon shape equals a new polygon shape for this specifically. That way we have that shape set up. And we're going to change the way we do this a little bit too. So you can see that we have, we're setting this to the origin, and then we're doing like this offset thing, which is just not the best way to do this. Instead, what we can do is we can say, set this to the offset, and then we can just get rid of this, which is much simpler than what we were doing there. Okay. And then finally, we can say fixture def. So this is like the fixture definition equals a new fixture def. We'll say fixture def dot shape equals the shape. So we assign the shape, then fixture def dot density equals 1. This is important just so that you have a uniform density or whatever. If you wanted to be more physically accurate, you could change this to something and actually make it customizable and stuff. Then we could say fixture def dot friction equals rb dot get friction, which I'll pin that, and we can do that a little bit later when we work on more physics. Then we'll say fixture def dot user data. This is the important part, okay? Is equal to box collider dot game object. So we've assigned this to the fixture's data. Now we will be able to access this, okay? Then we'll say fixture def, another thing that we're going to pin and do later, is sensor equals rb dot is sensor. And I'm just going to comment that out for now. We will add that later on. Then we can just say body dot create fixture, fixture def, and that should take care of everything for us. And then up here, I'm just simply going to say, instead of this, we can say add box collider 2D, and we'll give it the rigid body. And then we can say for the box collider, and we should be good. And I'm going to change this to an if, because we are going to want to add multiple colliders to a single game object, and this will just allow us to do that. And then also we're going to move this up here, and we're going to get rid of shape. We're going to get rid of this, and we're going to implement circle collider later on as well. Okay, so just a few different changes, sort of changing the way we do this a little bit. We'll make it nicer in the future when we add in more physics functionality. Anyways, the whole point of this, and one other thing we want to do as well too, is say up here, because we will probably want to get it here too, bodydef.userData is also the rb.game object. So all user data will always be game object, whether it's attached to a collider or whether it's attached to an actual body. It is always going to be the game object, which is good because now we can go into contact listener and we can say game object, object A equals cast to a game object, contact.getFixtureA.userData. And what this should do is get us that game object that we set. And I'm just going to change that to get user data. Shouldn't make a difference. But anyways, that's just going to get us that user data that we set at the beginning. And then we're going to do the same thing here. Just change this to contact.getFixture b.get user data. Same thing. Then what we're going to do is the world manifold, which is sort of the collision information. It gives us the contact normal, which faces we're colliding, all sorts of different things. So world manifold is very useful, and it gives it to us in world coordinates instead of local coordinates, which is nice. So we're going to say world manifold equals new world manifold, and we can get the contact information in world coordinates by just saying get world manifold. And we pass it the manifold. And so this uses the contact, which we were passed, and sort of converts it to world coordinates instead of local. And then we can say vector2f a normal. So this is object A's contact normal, basically the direction the other object is hitting A at, is equal to a new vector2f, world manifold.normal.x, world manifold.normal.y. Okay? So that is it for A, and then vector2f b's normal is just going to be the same as vector2f a normal, except we're going to negate it because B, everything is acting the opposite direction for B. So we just want to make sure to keep that in mind when we think about B's normal. It's local stuff is sort of opposite to what it is to A. Then we can say for component C in object A dot get all components. And we'll go ahead and import this. We will say c.beginCollision, which is the function we will add. Object B, so it's colliding with object B. Its contact is the same contact, so we'll just forward this contact information if they want anything extra. And then we'll give it A's normal, so the contact normal according to A. And then we'll just do the same thing for component C in object B dot get all components, c.beginCollision, object A, because according to B's components, it's colliding with object A. We'll give it the contact and we'll give it B's normal. So we basically just call these on both objects because for every contact, we will only get called, this pair of objects that are colliding will only be called once. And so we're basically going to go notify each component in each of their respective game objects that they were collided with. Let's go ahead. We want this function definition. I'm going to copy that and then we'll go to component. And I'm just going to add it like right above I am GUI right here. Okay, so let's say public void begin collision. Actually, we copied that for a reason. This is a game object. This is a contact, and this is a vector2f. Okay, and we're going to go ahead and import this from Box2D. And if you wanted to make this completely agnostic to the physics engine, abstract the contact. That way you're not depending on Box2D explicitly like we are here. I don't care too much because Box2D is a pretty good library, so I don't see myself changing that. But yeah, we basically have this begin collision thing. And instead of calling this object B, I'm going to call this colliding object. This is the contact, and this is the hit normal. Right, so this is the normal according to us, the hit, the direction of the hit. Right? And we're basically going to do the exact same thing, except we want end collision, right? We want to know when the collision is over. And a couple other ones that you may not be familiar with is preSolve and postSolve. And these are other things that Box2D gives us, which are useful in certain scenarios, which we will find out later on in the series when we go to actually use these. preSolve is good for like one-way doors. So basically if you want to jump up through a block, but you want to have it solid on the top, this is very useful for that and for other scenarios, which we will see. Let's go back into Jade Contact Listener now. We can see that all the errors resolved here. And guess how easy it is for us to implement the other things? Well, it's so easy. We can just go paste, paste, and paste. Very nice, except we do want to change. This is now end collision. Make sure to fix that. preSolve is now preSolve instead of that. Fix that, fix that. And postSolve is now postSolve. And fix that, fix that. And preSolve and postSolve are called, so like what ends up happening, and you can read this in Box2D's documentation, preSolve gets called, then it calls begin contact, and then it calls endContact, then it finally calls postSolve. So it's exactly what it sounds like. So that basically means that none of the impulses have been applied to the object. So in preSolve, you could say, hey, actually, I don't want you to solve this. Say it's the one-way door. You're like, no, I want it to collide through this. Then you can tell it to stop solving for this, and then it'll stop. So we will actually do that later on. So that is our contact listener done. All right, very quickly, let's talk about raycasts. Raycasts are an important part of a physics engine and something that we will definitely want to add support for. So we will have a function that returns some raycast info, and we'll just call this raycast, and this will have a game object, the requesting object. So who is asking for the raycast? This could be null, and that is perfectly fine. Then we'll say vector2f point 1 and vector2f point 2. So this is basically the start of the raycast and where you want the raycast to end. Then what we can do is we can say raycast info callback equals a new raycast info requesting object. And you'll see why I called this a callback in just a second. The way Box2D implements this is kind of weird. I guess this is probably the easiest way he could have done it, but it was confusing to me at first. What ends up happening is we say world.raycast. And you can see this takes in a callback, and we have to make a function that basically Box2D will call us once it finds the results. And we set it to our callback, and then we give it 0.1 and 0.2, and then we can say return callback. So let's go ahead and create another component inside of Physics2D, and we'll just go ahead and call this raycast info, okay? And this raycast info is going to implement raycast callback. Okay, and we want to make sure to hit Alt Enter and just implement the method. So we get this one method, and if you read up on the documentation, he goes into extensive detail about how this works, which we'll talk a little bit about. So first of all, I'm gonna say this contains a fixture. So this will be the fixture that we hit. This contains a vector2f point. This is the point that we hit, right? I guess we could call that the hit point. It doesn't matter too much. And then we've got a public vector2f normal. This is the normal of the hit that we got. So what direction did we hit it at? Public float fraction. This is the fraction of the distance along the vector that we hit it. So 50% would be right in the middle of our 0.1 and 0.2. Public Boolean hit is something we'll have, which just tells us whether we did indeed hit something or whether it was unsuccessful and we hit nothing. And then game object. Requesting object is, as we talked about, just the object that was requesting for this callback, which could be null, perfectly fine. And actually, we want that to be private because the user doesn't care about this. But we will have one last thing, which is the game object, the hit object. So this is the object that we ended up hitting. Then you can see basically what we're going to want to do is just have a public raycast info. This takes in a game object, obj, and we'll just say fixture equals null. Point equals new vector2f. So we'll just sort of initialize everything to be nothing. We'll initialize the normal. The fraction is 0. We didn't really hit anything. Hit equals false. And then we'll say hit object equals null. This dot requesting object equals the object that they passed in. Then inside of here, this is the callback that fit Box2D calls. So what happens is inside of Physics2D, we say, hey, Box2D, we want you to send a raycast into the world. And real quick, this is bothering me. Change this to new vec2, and this should be 0.1.x, 0.1.y. Change this to new vec2, 0.2.x, 0.2.y. Okay, that's better. Anyway, so what happens is we say, hey, Box2D, send a raycast into the world, and I want you to call this function once you find it. Now, this is all happening synchronously. It's not like this is going off and doing something, and then the game engine just continues. No. What happens is we call this function, at least from what I can tell. Correct me if I'm wrong. We call this function. So Box2D goes and does some stuff, which I just clicked into it, which doesn't really help us much. Does some stuff, and then once it finally finds something, then it'll call our callback, right? So then it calls this function that we've implemented in our interface. If it doesn't find anything, it doesn't call anything, and that's why we initialize it here, everything to basically say we didn't hit something. But if it does, it calls this with this information. The fixture it hit, you can see it just says vec2, vec2.1, so it just initialized these to kind of not very helpful information. but this is basically the point we hit. This vector2 is the normal, and you can see this all if you look at the documentation, and this float is the fraction, okay? And what we can say is if fixture.userData, so if we hit the requesting object, if we hit the requesting object, we don't want to return that because the game object doesn't care about that, right? The raycast, we want to see if we hit something other than the person who's requesting it. So what we can do is we can say return 1, which if we return this, Box2D will continue looking. So this is why he implemented it as a callback, because what happens is we say, we don't really want this one, keep going and see if you find anything else. And then Box2D continues to go, then if it finds something else, it calls this again. And then what we can do is say, if it wasn't that, then we can say, oh, cool, well, this fixture equals the fixture. This point equals a new vector 2f, point.x, point.y. This normal equals a new vector 2f, normal.x, normal.y. This fraction equals the fraction. And this hit equals fraction does not equal 0. If the fraction is 0, that means we did not hit anything. I don't think we ever actually encountered that, but it's good to have that just in case. This dot hit object equals game object var or fixture dot user data. So we basically just set that. And then what we can return is the fraction. And if we return the fraction, then that tells Box2D, okay, we're done now, you can stop. If we return fraction or 0, I believe, it basically just signals this to stop and it will stop. And I may be misquoting that a little bit. If you return fraction, what it'll actually do is it continues to go. And if it hits any other objects, it'll return those as well, which is kind of weird. We won't go into that. That's a little bit more complicated. So just think of this as it could be any one of the objects within the raycast. This is not necessarily the first object the raycast hit. This could be any object within the raycast length. So keep that in mind. If you want to make this a little bit better, look at the documentation. It'll help. But yeah, that should be good though. And if we go back into Physics2D, you can see that our raycast should work fine. And we now have a way to raycast into our world. Now let's go ahead and let's fix up our Physics2D class a little bit more because I do want to abstract this stuff out real quickly. Very quickly, let's go up to the body definition. We will be adding a couple more things to our rigid bodies that will be useful. One of these will be gravity scale. So we'll say rb.gravity scale. And then we will also be adding in angular velocity, which I don't believe we have. Yeah. So we'll be adding both of these in just so that you can set these values if you want to as well. And then one other thing we will want to do is right here, after we create the body, we actually want to set the mass. So we'll say body.mass equals rb.getMass. And I'm not sure if it matters when you do this stuff, but this is the order I've done it and it works this way. So I would recommend following a pretty close ordering to this. Okay, and then we'll actually get this circle collider working correctly. So instead of doing this, what we're going to say is add circle collider, and we're going to create another function that's helpful, and we'll give it the RB and the circle collider. So we'll go ahead and create this function right below Box2D collider. So we'll say public void add circle collider, and this just takes in a rigid body, RB, and a circle collider. Circle collider. Then we will simply say body equals rb.getRaw body. Basically, we're going to be doing something very similar to all of this. So I'm just going to copy that, paste it. And instead of doing polygon shape, we're just going to have a circle shape. So let's say circle shape equals new circle shape. Then we can get rid of most of this. We'll go up to there. And we'll say shape.setRadius to circle collider.getRadius. And we'll say shape.mp, which this was kind of hard to figure out, but basically that's the offset. So it's similar to our Box2D's offset except for circles. And we'll say this is set to circle collider.getOffset.x, circle collider.getOffset.y, and that should be good. And then we've got the fixture def. Fixture def should be mostly the same. Except user data is now a circle collider.gameObject, and everything else should be good. I'm going to remove these, that way we go ahead and actually implement these. Okay, and we're going to add a couple more useful functions, which we will be using as well, which is public void reset circle collider. This will take in a rigid body, RB, and a circle collider. And this is simply going to reset all the colliders to this new circle collider. So we'll say body equals rb.getRawBody. If body equals null, we will return because there are no colliders and there's not a physics object really. Then we're going to say int size equals fixture list size body. And fixture list size is a function that we will create, which will basically get us the number of fixtures. So we'll just go down here and we'll say private int fixture list size, which takes in a body, box2D body. And this will say size equals 0. Fixture equals body.get fixture list, which will get us the first fixture in this singly linked list. And we'll say while fixture does not equal null, size plus fixture equals fixture.next, which should just iterate through that list, and then we can return the size until we hit the end of the list. So that's how we'll get the size. And once we get the size, we're just gonna say for int I equals 0 until I is less than size, I++, and we'll say body.destroy fixture, body.get fixture list, which should just destroy all of the fixtures we have in there, and I'm missing a semicolon. And then we're gonna say add circle collider after we do all that, RB circle collider, and we will want to reset the mass data since we've changed a collider. And we're gonna do something very similar except for box colliders. And I guess I should have put that above circle colliders, but it doesn't matter. So we'll say reset box2D collider, and this will take in a box2D collider. We'll call this box collider. And we'll simply change this to that, and we'll say add box collider. And yes, I know there's a lot of repetition and everything in here, but it works and it's not too much of a hassle for me. Ideally, you'd probably want to abstract this into its own function just to make sure you're not repeating yourself like I am here. These are helper functions that we will be using in the future, but for now, it's fine. Now, we want to add in friction, is sensor, all these things to our rigid body. So let's go ahead and go into our rigid body very quickly. And we're gonna go ahead and say private float friction, which is a value we'll want. I'll just initialize it to 0.1, doesn't matter too much. Public float angular velocity equals 0. And I chose public and private for these just because I was getting lazy and didn't want to make these private anymore. I really don't care too much in this case. So you can make these all private if you want to be super safe. They'll say public float gravity scale equals 1.0f. So gravity is just normal box2D gravity initially. And then we'll say private boolean is sensor equals false. So it is, oh, and a sensor too. What is a sensor? Well, a sensor is basically like a dynamic object in the world that doesn't actually affect anything. So it doesn't collide with anything, but it still calls beginCollision, endCollision, all that stuff. It just doesn't actually bounce off of the things. So that's all a sensor is. And they're useful if you want like a trigger or something. You could just make it a sensor and it's a trigger now. It triggers when things enter into it. So that is good to have. And we will of course want some helper functions here. So we'll say public vector or void add velocity, which takes in a vector2f force to add. So I guess this should be called force, but it's fine. And we'll say raw body dot apply force to center, new vec2 velocity.x velocity.y, which should add a velocity. And we'll say if raw body does not equal null, just to be safe, because we don't want to apply that on accident. So we can add the velocity. We will also add a way to add an impulse. So let's say public void add impulse. Oh, and that's actually what I did here. So whoopsie. So this will be impulse. And we will do this inside of add impulse. For this one, we want to apply or add a force, which I think is just, okay, yeah, apply force. And the point we want to apply this to is the raw body dot get center, I believe. Let me just double check. We should actually be able to just say apply force to center here, get rid of this. And for the impulse, we will want to say raw body dot get world center. Okay, there we go. That way we just add it to the center of the objects and give it a little bit easier for our users of our engine. They don't have to think about that stuff. They just say add impulse and don't have to think about where it's adding it to. Inside of set velocity, we're just gonna change this to dot set velocity. And then we'll say if raw body does not equal null, then this dot raw body dot set linear velocity to a new vec2 velocity.x velocity.y. So we're just adding it to the raw body as well as our thing to keep track of it. And then inside of angular velocity, well, we don't have that yet. So we'll add that right here. We'll say public void set angular velocity, and this will just take in a float. And the reason angular velocity is one dimension instead of two dimensions is because that's how angular velocity works. If you think about it, it's only spinning on one axis, which is the z-axis, whereas linear velocity is a two-dimensional force. And we'll just say if raw body does not equal null, this dot raw body dot add angular, or I'm sorry, set angular velocity to that guy. And we'll also want to do this for gravity scale. So we'll say set gravity scale, right? Just a lot of helper functions to make our lives easier once we actually start coding this game. So we'll say set the gravity scale, and then we'll say this dot gravity scale equals gravity scale, and then we'll say set gravity scale to this, and we should be good. And then we'll add another function. This will be public void set is sensor. So this will just set it to be a sensor. So we'll say that's equal to true. We'll say if raw body does not equal null, then window.getPhysics, which is something we will also add too. So we'll say window, import that dot get physics, which we don't have. We will add that in a second, and then we'll say set is sensor to true. And we'll say public boolean is sensor, and this will just return this dot is sensor. And we'll have one more, public void set not sensor, which will set it to be not a sensor. So we'll say is sensor equals false. If raw body does not equal null, then window.getPhysics dot set not sensor. Oh, and this should be this, not true. So we're just gonna do this over here as well. Okay, and that should be good. We just need to go to our window real quickly, and we'll add in a function, which is just public static physics 2D get physics, which will return get dot current scene dot current scene dot get physics. Should be good. And then we will go ahead and let's see what's wrong with this. Oh, and this is IntelliJ is just warning me about this. We don't need to access this via get. We can just say current scene since current scene is static. So I'll fix that real quickly. And then we'll just go to current scene. We'll go into scene, and then we'll add in a public void get physics, which should just return this dot physics. Okay, and then if we go back into window, that should be good. No errors. Nope, I do have an error. Physics, get physics inside a scene should return physics 2D. Whoopsie. Okay, then if we go into window, window is good. If we go back into physics, or I'm sorry, rigid body, we will have another error because we don't have set not sensor and set is sensor. So let's go back into physics 2D, and I promise this should be the last physicsy thing we have to do today. And we can go up here and we can just say public void set is sensor, and we will take in a rigid body, and we'll say body equals rb.get raw body. If body equals null, we'll return because we can't really do anything, and we'll say fixture equals body.get fixture list because we actually set the sensors on a fixture basis, and if we want to set it on the whole raw body, then we have to go through all of them. So we'll say fixture.mSensor equals true, and fixture equals fixture.mNext. Should be good. And then we will add in set not sensor. If we go ahead and just copy that, set not sensor, and we'll just change that to false. And if we compile, we are not out of the woods yet. Let's go into rigid body and add in get friction. So we'll just say public float get friction, return this dot friction. Okay, if we go and run this one more time, there we go. Now we can run it, and we should be able to add objects. We can select multiple objects at a time. We can duplicate those objects if we want to. We can go ahead and add Mario if we really want to. Deselect objects just by clicking off of them. We can play, stop the scene. As you can see, we are getting closer and closer to a full engine. In the next episode, we will be getting much closer to what I have here. So we'll probably have to add in pillbox colliders, which is what I have on Mario here. And we'll start coding Mario. We should be in a good place. And you can see I've tweaked it a little bit more because I didn't quite like the way the controls were working. So we'll be learning about how to like basically code the whole game. Add in variable length jump times. You can see that I can jump small or big if I want to. These blocks all work. We can pop out a mushroom. We can grow into Big Mario. If we hit a bad guy, if I fail. Let's see. I get hurt, and then I get invincible for a little bit, and then if I hit him again, I die. So we'll be adding all this stuff. It's a fully working game. I still have a couple things left to implement, but I'll get those done, and then we'll basically just build this. All right. So I hope you guys are looking forward to that, and I will see you in the next tutorial when we actually start implementing the game. If you like this, don't forget to hit like and subscribe, and I'll see you then.